Okay, now let's look at another example of extended ACL. Okay, here we created the ACL 101. Okay, three statements. Okay, the first statement of ACL 101 is to deny packets. Okay, what kind of packet? TCP packet. From where? The source IP is from the network 192.168.11. Okay, so from this network. Okay, okay, so this is the wildcard. Is there any source port? Okay, so this is empty. So source port is empty. So there's no need to check for source port. Okay, destination IP. Destination IP is here. Okay, this is the destination IP address. The destination IP address is going to the 192.168.10 network with the wildcard 000255. So this is the destination network. This is the source network. This is the destination network. And what kind of protocol is this ACL trying to deny? It's trying to deny the port 21, TCP port 21, so that when any PC in this network trying to access port 21 FTP, FTP is port 21, R1 will drop the packet. We will not allow any PC from this network to FTP to any PC in this network. Okay, the second statement is also similar, except it's for FTP data. FTP actually uses two ports. Port 21 is a control port, which allows you to log into the FTP server, browse through the directory, and then once you select a file that you want to download, you double click on the file, port 21 will be open for you. It's a FTP data port for you to transfer the file. So here I'm also going to deny. And then the final statement. If you remember, previously we said that an ACL cannot contain only deny statement. It must have at least one permit statement, because at the end of all the ACL there's an implicit deny any. So if you have all the only deny statement, and the last statement is a implicit means it's a hidden statement. It's a hidden deny any packet. Then basically this ACL will drop all the packet. You're effectively shutting down the interface. So here you must have at least one permit statement. So here is the permit IP. Any from any to any. So this will allow any packets. That is IP. If you remember TCP IP, so IP is the packet, or is the protocol that carries TCP packet, UDP packet, and also ICMP packet. So when you permit IP, you are also effectively permit all the packets that's carried by IP, including TCP, UDP, and ICMP. So here effectively, I'm allowing all other packets. I'm only denying the FTP packet. Now where to apply this ACL? So I'm going to apply it on R1. R1 on the FA01 interface going in. Going in. So this will effectively control access of this source network to go to this destination network in this direction. So this is a second example of extended ACL. Let's look at a third example of extended ACL. This extended ACL is to deny telnet from one particular subnet. That means I will not allow any PC in this subnet to telnet to anywhere. So here again is extended access control list. I'm going to deny. Telnet is a TCP protocol. So again, TCP from where? The source is here. Which is the 192.168.11 network. So this is the source. To where? To any possible destination. So the destination IP is any. That means it cannot telnet to any IP address. So here I do not need to check the destination. It covers all the destination IP address. Any source port specified. No source port specified again. Again, also do not need to check source port. Do not need to check destination IP. Do I need to check the destination port? Yes. To make sure that I'm going to deny only telnet packets. All other packets are all permitted. Same thing, I'm going to apply it on the FA01 interface, and the source is here, so it's going into the FA01 interface. So we have covered standard access control list, which include the number access control list and the name access control list. Okay, in standard access control list, we have the number access control list. Okay, we also have the name extended access control list. Okay, configuration is similar. Okay, let's look at how do we configure name extended access control list. Okay, by using an example. So looking at here, okay, again, remember for name access control list, we must start with the keyword IP. Okay, and then access list. Okay, now we are going to create extended access control list and then the name of this extended access control list, okay, which is surfing. Okay, this example is similar to the first numbered extended access control list that we covered. That means we are going to permit web surfing for a particular subnet. So here, web surfing is port 80, port 443. So once I created this command, the prompt will change to extended name ACL, and then I start to create the permit and deny statement. So the first statement is to permit port 80. From where? Okay, port 80 from this source. Okay, this is a source to any network, to any internet. Okay, same for port 80, 443, both are TCP protocol. So this will effectively allow my 192.168.10 network, the source, to go out to the internet as long as they are trying to connect to port 80 or port 443. Okay, when they connect a server, okay, the server will send a reply packet back. So similarly, I must allow the reply packet to come back. How do I apply? So how do I allow the return packet to come back? I created another access control list, okay, and the name is called browsing, to allow, okay, the return packet from any. So now this is the internet now. So from any source from the internet to come back to my, okay, this becomes the destination IP, to come back. Okay, so in the return traffic, this becomes the destination. Come back to my 192.168.10 network. Okay, I allow this kind of packet to come back as long as it's an established connection. That means someone from inside, okay, trying to connect, and the return traffic come back, I will allow. Now let's look at the establish command with more in details. Okay, okay, this establish command is important because the internet is an untrusted network. Okay, so because it's an untrusted network, okay, there's a lot of hacker PC, hacker server that is there that is trying to enter into your network. So how do you ensure that this kind of hacker PC or hacker server, okay, to prevent them from entering to your network? Okay, it's almost impossible to filter off this kind of PC because there are millions of IP addresses inside this internet. So the only thing we can do is to trust our own source. Okay, that means if, okay, the packet going out, okay, and the return traffic come back, we trust that this source is going to a good website, a legitimate website, and the return traffic is a good one. So for example, someone from here trying to go to Twitter. So Twitter, okay, we trust that it's a good website, and when he send back the return traffic, we allow the return traffic to pass through. Okay, so we allow established traffic packet to pass through. But if a hacker here, he tried to enter on his own, that means no one from inside trying to connect to him, but he tried to enter on his own. Okay, this kind of packet will not be allowed, okay, because it's not an established packet. Okay, so what happened to this kind of packet? Remember, there's a implicit deny any statement right at the end of each ACL. So there's always a deny IP any. Okay, this ACL, which is hidden but it's always there. You will drop all the packet that is not found in the, that does not match any of the access control list. Okay, so this establish command is important. Okay, because it's impossible to filter out, okay, all the untrusted network or untrusted or to hacker PC or a hacker server on the internet. So what you do is you only allow the return traffic to come back, not someone from the internet world who try to connect in. Okay, you will not allow them to come in. So similarly, how do you apply this ACL? Okay, so same thing. I'm going to apply it on R10000 interface. Okay, for the surfing one, I will apply it going out. Okay, for the browsing, I will apply it going in. Okay, same as the numbered extended ACL, that the example that I gave you.